Hello everyone, welcome back to our channel Problematical. Today we'll discuss exercise 3.2, that's from third chapter Trigonometric Functions from class 11th Maths NCERT. First question, find the values of other 5 trigonometric functions in exercises 1 to 5. In the first part, cos x value is given, you have to find the remaining trigonometric functions. So cos x is equals to minus 1 by 2. Another piece of information given is the angle x lies in the third quadrant. Now we know that in the third quadrant only tan and cot will be positive and remaining all trigonometric functions will be negative. So sec x is equals to 1 upon cos x. Cos x is minus 1 by 2, so sec x will be equal to minus 2. Now from sec x we can get the value of tan x. We know that sec square x is equals to 1 plus tan square x, which means tan square x is equals to sec square x minus 1. Sec square x is minus 2 whole square minus 1, which is equals to 3. So tan x is equals to 3. Tan square x is equals to 3. Taking square root on both sides, tan x will be equal to plus minus root 3. Now in the third quadrant, tan x is positive, so tan x will be equal to plus root 3. From tan x, we can get the value of cot x. Cot x is equals to 1 upon tan x. So cot x is equals to 1 upon tan x, and cot x is also positive in the third quadrant. It will be positive 1 upon root 3. We also know that sine square x plus cos square x is equals to 1. Therefore, sine square x is equals to 1 minus cos square x. This is equals to 1 minus 1 by 2 whole square. This is 1 minus 1 by 4, which is equals to 3 by 4. This is the value of sine square x. Taking square root on both sides, where sine x will be equal to plus minus root 3 upon 2. Here, we know that sine x has to be negative in the third quadrant. Therefore, sine x value will be equal to negative root 3 upon 2. Also, your cosec x is equals to 1 upon sine x. So, you can write cosec x is equals to 1 upon sine x. This is equals to minus 2 upon root 3. So the other trigonometric functions are as follows. Sin x is minus root 3 upon 2, cosec x minus 2 upon root 3, cot x 1 upon root 3, tan x root 3, sec x minus 2, and cos x minus 1 by 2 is given. Next, sin x. You now have to find the value of sin x. So sin x, you are given the value of sin x as 3 by 5. Sin x is equals to 3 upon 5 positive, and x lies in the second quadrant. In the second quadrant, sine and cosec are positive, rest of the trigonometric functions are negative. From sin x, we can get the value of cosec x and cos x. So cosec x is equals to 1 upon sin x, which is equals to 5 upon 3. Next, cos square x. Cos square x is equals to 1 minus sin square x. So cos x is equals to root of sin square x minus 1. 1 minus sin square x. 1 minus sin square x. This will be equal to root of 1 minus 3 upon 5 whole square, which will give you 25 minus 9, which is 16. 16 upon 25. 3 square 9, 5 square 25. So this is 9 upon 25. 1 minus 9 upon 25 is equals to 16 upon 25. So taking the square root, you get plus minus 4 upon 5. Now if you have a plus minus 4 upon 5, cos x is negative in the second quadrant. Hence you will consider cos x is equals to minus 4 upon 5. Next, from cos x you can get sec x. So your sec x value is equals to 1 upon cos x, which will then be equal to minus 5 upon 4. You have sin x and cos x. You can get the value of tan x. Your tan x is equals to sin x upon cos x, which is 3 upon 5 upon minus 4 upon 5. This is minus 3 upon 4. Cot x is equals to 1 upon tan x, which will be equal to minus 4 upon 3. So these are your values. It was given sin x is equals to 3 upon 5. You got the value of cosec x 5 upon 3, cos x minus 4 upon 5, sec x minus 5 upon 4, tan x minus 3 upon 5, and cot x minus 4 upon 3. Next question. Cot x is given to you 3 upon 4, and you have to find out where x is in the third quadrant. In the third quadrant, we know that tan and cot are positive. Cot value itself given is positive. Cot x is equals to 3 upon 4, and x lies in the third quadrant. If cot x is given, then tan x will be equal to 1 upon cot x, which is equals to 4 upon 3. Now, 1 plus tan square x is equals to sec square x, which implies sec x is equals to root of 1 plus tan square x. This is equals to root of 1 plus 4 upon 3 whole square, which means root of 3 square 9, 9 plus 16 is 25 upon 9. Taking square root, you should get plus minus 5 upon 3. Now sec x in the third quadrant is negative. So sec x value will be equal to minus 5 upon 3. Cos x is equals to 1 upon sec x. This will give you minus 3 upon 5. Sin x is equals to root of 1 minus cos square x. This is equals to root of 1 minus 3 upon 5 whole square, which will give you 3 square 9, 5 square 25. 25 minus 9 is 16. So root of 16 upon 5, 25, sorry. Taking square root, we will get plus minus 4 upon 5. Sin x is negative in the third quadrant, so sin x value will be minus 4 upon 5. Cosec x is equals to 1 upon sin x. So this value will be equals to minus 5 upon 4. So you were given cot x is equals to 3 upon 4. Tan x came down to be 4 upon 3. Sec x as minus 5 upon 3. Sin x minus 4 upon 5. Cos x minus 3 upon 5. And cosec x minus 5 upon 4. Next. One second. Right. So now we have sec x. Sec x is equals to 13 upon 5. And x lies in the fourth quadrant. In the fourth quadrant, we have sec and cos. These two values as positive and remaining values as negative. So, one second. right? So in the fourth quadrant, we have sec x as positive and cos x as positive, and remaining all the trigonometric functions will be negative. From this, we can get cos x is equals to 1 upon sec x, which will be equal to 5 upon 13. Now, from cos x, we can have sin x. Sin x is equals to root of 1 minus cos square x. This is equals to root of 1 minus cos square x. Cos x is 5 upon 13, which is 25 upon 169. 169 minus 25 will give you 144, and root of 144, this will be root of 144 upon 169. This is plus minus 12 upon 13. This is the value of sin x. Sin x has to be negative in the fourth quadrant. Hence, sin x will be equal to minus 12 upon 13. From sin x, we can get cosec x. Cosec x is equals to 1 upon sin x, which is equals to minus 13 upon 12. Next, we have tan x and cot x. So, tan square x is equals to sec square x minus 1, and tan x will be equal to sec square x, root of sec square x minus 1. This will be equal to root of 13 square 169 upon 25 minus 1. 169 minus 25, 144, cross multiplication. This will give you root of 144 upon 25, which will be equal to plus minus 12 upon 5. Again, tan x is supposed to be negative in the fourth quadrant, hence tan x will be equal to minus 12 upon 5. Cot x is equals to 1 upon tan x, hence this is minus 5 upon 12. So, with this, we got the other trigonometric functions. Sec x is equals to 3 upon 5 given. Cos x is 5 upon 13. Tan x came down to be minus 12 upon 5. Cot x minus 5 upon 12. Cosec x minus 13 upon 12. Sin x minus 12 upon 13. Next, tan x. Now tan x value is minus 5 upon 12, and x lies in the second quadrant. In the second quadrant, sin and cosec are positive, and all the other remaining trigonometric functions are negative. So, tan x is equals to minus 5 upon 12, which gives cot x as minus 12 upon 5, because cot x is 1 upon tan x. Your sec square x is equals to 1 plus tan square x. So sec x is equals to root of 1 plus tan square x. This is equals to root of 1 plus minus 5 upon 12 whole square. This will give you 144 plus 25, which is 169. So root of 169 upon 144. This is plus minus 13 upon 12. Sec x has to be negative in the second quadrant. So your sec x value will be minus 13 upon 12. With this, we know that cos x is equals to 1 upon sec x, which will give you minus 12 upon 13. Now, tan x is equals to sin x upon cos x. We have tan x, we have cos x, so we can get sin x as tan x multiplied by cos x, which is minus 5 upon 12 multiplied by minus 12 upon 13. 12 and 12 will get cancelled, negative will be positive, and you'll end up with sin x is equals to minus 5 upon 13. Now, cosec x is equals to 1 upon sin x, so it will be minus 13 upon 5. With this, we got tan x is equals to minus 5.12, cot x is equals to minus 12.5, sec x is minus 13.12, cos x is minus 12.13, sin x is minus 5.13, and cosec x is minus 13.5. Next. Find the values of trigonometric functions in exercises 6 to 10. And the remaining exercises, the second part of the exercise, you are given trigonometric functions. You have to find the value of trigonometric functions. And certain angles are provided to you either in degree or in radian. EI stands for pi in this 8th question. First value is sine of 765. Sine 765 degrees. Now we know that trigonometric functions repeat itself in multiples of 2 pi, which means sine of 2 pi plus theta plus minus theta is equals to sine theta. And same goes for every trigonometric function. No matter what trigonometric function we use in place of sine, this situation will always be true. This condition will always follow. 2 pi stands for 360 degree. So you can write the same formula as sine of 360 degree plus minus theta is equals to sine theta. Also, this is not just 2 pi, it can be 2n pi. That means you can have any multiple of 2 pi. You still will come up with the same answer. So even if I write n into 360 degree, it will still give me the same answer, or 2n pi will give me the same answer. Now, 360 degree multiplied by 1 is 360 degree. 360 degree multiplied by 2 will give you 720 degree. Now, if you multiply it by 3, you will end up with 1080 degree. Now, this value 765 lies between 720 and 1080. You can easily write the 765 in multiples of 360 degree as this is sine of 720 plus some value. So subtract 720 from this, you'll end up with 45 degree. So you can write this 765 as 720 into 45. Why 720? Because it's a multiple of 360 and we are aiming for this kind of formula. So sine of 2 into 360 degree is equals to 45 plus 45 degree. So all you've done is modify the given angle in a form acceptable by us. This is n into 360 degree plus 45, n into 360 degree plus 45 plus theta. Theta stands for 45. So answer will be equal to sine 45 degree. Reason being sine n into 360 degree or 360 n 360 degree into n plus minus theta is equals to sine theta. This is your formula. So we know that sine 45 is equals to 1 upon root 2. So this is 1 upon root 2. That's your final answer for sine 765 degree. Now, second, this is 6th value, 7th value. Cosec minus 1410 degree. Now, 1410 degree. So continuing with our table, 360 degree into 4 will give you 1440. Now this 1410 is closer, lies between 1080, but it is closer to 1440. So instead of addition, we can also represent this minus 1410 in terms of subtraction. What is the difference between 1440 and 1410? It's 30 degree. So you can write this as cosec of need a negative. So 30 degree minus 1440 degree. Cosec minus 1440 can be written as cosec 30 degree minus 1410 can be written as cosec 30 degree minus 1440. This is equals to cosec of minus 1440 degree plus 30 degree, which is cosec minus 4 into 360 degree, multiple of 360 degree plus 30 degree. The n factor over here, n can be, n belongs to an integer. It can be positive or negative. So this, according to the formula, will give you cosec of 30 degree. We know that cosec of 30 degree is 2 because it's inverse of sine 30, which is 1 by 2. Next, 1 second. So now the angle is given in terms of radians. 8.1 tan of 19 pi upon 3. So all you have to do over here is convert this into a multiple of 2 pi. To get to this value, you can also use your other trigonometric functions, like pi by 2 plus, pi minus. Even if you get into any of the standard notations, pi plus theta or minus theta, pi by 2 plus minus theta, or 2 pi plus minus theta, or 3 pi by 2 plus minus theta. Any form will give you, help you to reach your answer properly in a simplistic manner. But we will mainly try and focus on this value. Anyways, 19 pi by 3. The number before pi is greater than 3. So it can be represented as the addition of multiple of denominator as well as some other value. So 19 can be written as tan of 19 is 18 plus 1, and 18 can be written as 6 into 3. So you have 18 plus 1 into pi upon 3. This is equals to tan of 18 pi by 3 plus pi by 3. So you multiplied with pi by 3 on both inside the two terms of the bracket. This is equals to tan pi plus pi by 3. Now this is equals to tan 3 into 2 pi plus pi by 3. So it is equivalent to n into 2 pi. This can easily be written as tan of pi by 3. Since tan n into 2 pi or 2n pi plus minus theta is equals to tan theta. Now tan pi by 3 is 60 degree, which is equals to root 3. So this is your answer for tan 19 pi by 3. Next. Next, you are supposed to calculate sine of minus 11 pi by 3. Numerically, this is minus 11, so it is smaller than 3. It can be represented as a minus 11. So you have 12 minus 1, 1 minus 12. Sine of 1 minus 12 in place of minus 11 pi by 3. This is equals to sine pi by 3 minus 12 pi by 3. This is equals to 4. This is equals to sine minus 4 pi. I'm writing before, and minus 2 is taken multiple. This is minus 4 pi plus pi by 3. Again, n has to be an integer, so this can be easily written as sine of pi by 3. Sine pi by 3 is root 3 upon 2. This is value of sine minus 11 pi upon 3. We will have to give the reason that sine of 2 in pi plus minus theta is equals to sine theta. Next. Cot of minus 15 pi by 4. Again, minus 15 can be written as 1 minus 16, and 16 is a multiple of 4. All you need is one value, 1 minus 16 pi upon 4. Out of the two numbers whose addition or subtraction that you're taking, one number should be a multiple of the denominator. That is what you require. And the other number should be smaller than this denominator. This is cot pi by 4 minus 16 pi by 4, which is 4 pi. Again, it can be written as cot of minus 2 into 2 pi plus pi by 4. This again can be written as cot of pi by 4. We know that cot pi by 4 is 1. So this is the value of tan minus 15 pi by 4. This concludes this exercise. Thank you.